Hey, it's Calc&Compile, your shortcut to simple math and computing. Today we are starting our brand new C programming series from the very basics all the way to the master level. Before we write a single line of code, let's take a quick journey through the history of C, how it began, why it was created, and why it still powers so much of the tech world today. Where did C come from? C was created in the early 1970s by Dennis Ritchie at Bell Labs in the United States. At that time, operating systems were written entirely in assembly language, super fast but incredibly hard to maintain. Dennis wanted something flexible enough to handle hardware directly, yet easier to read and reuse. That's how C was born, and it quickly became the language used to rebuild the Unix operating system. Unix succeeded, and C came along for the ride. How did C evolve? C did not appear overnight. It evolved through a series of languages. BCPL in 1966, then B in 1969, finally in C in 1970. Later in the early 80s, C++ added object-oriented features, and by 1999, ANSI standardized C so that program could run consistently across computers. The later versions, C99, C11, and C17, introduced things like inline functions, multithreading, and performance refinements, but kept the same solid foundation. What's amazing is that C code written decades ago still compiles today. Why was C created? C had one simple mission: to rewrite Unix. Assembly language was powerful but painful. Thousands of lines just to perform basic tasks. Let me show you a small comparison. On the left, we have 4 lines just to add two numbers. On the right, in C, one clear line. int result equal to 5 plus 3. That's the beauty of C. Close to the machine language yet readable by humans. Fast, flexible, and portable. Exactly what Bell Labs needed. Key features of C. So, what made C so special? First, it's a procedural language. Everything happens through well defined functions. Second, it gives low level memory access. Using pointers, letting programmers control how exactly memory is used. Third, it's fast and efficient. It compiles directly to the machine code. Fourth, it's portable. The same code can run on multiple systems with very few changes. Fifth, C sits right in the middle. We call it a mid-level language because it balances power with simplicity. And finally, it's strongly typed. You must declare every variable's data type, which keeps your program structured and bug-free. All these features made C the perfect bridge between hardware and high-level logic. Importance and applications of C. Even after 50 years, C hasn't gone anywhere. It's the foundation of modern programming languages like C++, Java, Python, C#. All inherit their syntax and concepts from C. It's the core of operating systems like Unix, Linux, and parts of Windows too. It runs embedded systems and IoT devices, which where performance matters most. Databases like MySQL and PostgreSQL are written in C. Even compilers, drivers, and game engines depend on C. In short, wherever you need speed, control, and reliability, you will find C behind the scenes. And C standard. Because C became so popular, developers needed a standard that would work everywhere. In 1989, the ANSI C standard, also known as C89 or C90, was published. It defined how C should behave no matter what machine it ran on. C99 modernized the syntax, C11 added multithreading for modern processors, and C17 fine-tuned stability. The language barely changed in spirit, and that's why C code written decades ago still works today. Influence of C on other languages. Every major programming language today owes something to C. C++ extended it with object-oriented design. Java borrowed C syntax and structure. She has adapted it to Microsoft's .NET platform. Python and JavaScript both use interpreters written in C. Even modern system languages like Go and Rust were built on C's principle. So when you learn C, you are not just learning one language, you are learning the DNA of nearly every language out there. Why C still matters today? C remains one of the most relevant languages ever made. It's the best way to understand how computers truly work, how memory is managed, how code talks to hardware, how performance is optimized. Learning C builds a mindset that makes every other language easier. If you want to become a serious programmer, this is exactly where you should start. That's it for this video. In the next video, we'll set up our environment, install the compiler, and write our very first C program together. So get ready, we are about to start coding. Thanks for watching. Don't forget to like, share, and subscribe. See you in the next one.